Let's go ahead and do it. So this is called a proof by contrapositive. So our first indirect proof is proof by contrapositive. Like that. And so the way it's going to go is we're going to say proof. And then if you're going to do a proof by contrapositive, you always tell your reader what you're doing. So you literally say proof by contraposition. You can say contraposition or contrapositive. I don't care. I guess contrapositive is a noun. Contraposition is more like a verb or some crap. Adverb? Someone put in the chat whatever part of speech this is. But the point is, you're saying the same thing. So proof by contraposition. Yeah. So what you do then is you just do basically a direct proof on the contrapositive, right? But the indirect part is thinking with the contrapositive. And so we're just going to do like we normally do. So we're going to say let n be any arbitrary but particular integer. I don't know why I paused. So let n be any arbitrary but particular integer. And now assume the hypothesis. Assume n even. So we've just assumed that we're in the domain and the hypothesis is true. Let's prove the conclusion. Then by definition of even, there is some k such that, or some k in z, it's got to be an integer k, that's the whole point, such that n equals 2k. Now let's consider n squared. N squared equals 2k squared by substitution, which equals 2k times 2k by definition of exponentiation. We can actually put letters there. Exponentiation. This is your initiation and exponentiation. And this is going to be 4 times k squared by simplification. And this is going to be 2 times 2k squared by factoring. So we've almost done it, right? We've written n squared. We said that's equal to 2 times 2k squared, right? And all you have to do is prove that 2k squared is an integer, and they've proven that n squared is even. And that one quiz should have told you that, oh yeah, that's why we need to prove 2k squared is an integer, because if 2k squared is not an integer, we haven't proven crap about n squared, right? For example, 5 equals 2 times 2.5, but 5's not even, right? Because this is not an integer, right? Every number is 2 times something. What makes it even is got to be 2 times an integer. That's the important part. So the reason it's an integer, of course, is note 2 and k are in z, and the integers are closed under addition and multiplication. So 2k squared in z, thus 2, or I'll say thus n squared, which equals 2 times 2k squared, is even by definition. Because 2 times an integer.
Professor, I can't see the end part.
Oh, sorry about that. So, I mean, this proof is really simple and really just basically the exact same things we've done before. The key brilliant part of all of this was using the contrapositive, proof of contraposition. Look at the contrapositive, the conditional, rather than the original conditional. In this case, made it a ton easier to prove. Any questions? Going once? Okay, well, I hope this makes sense, right? I think this is a really simple example. I think it made sense. And
when we do these proofs, do we have to say somewhere that it's indirect or direct?
no, a direct proof, you don't have to say anything. Kind of, if you say nothing, it's assumed it's a direct proof. If it's an indirect proof, if it's like a proof by contrapositive, just write at the top, like I did, proof by contrapositive, to let the reader know what you're doing. But like every indirect proof we do will have a name. And so you just say whatever this specific one you're doing is. Does that make sense?
Yeah.
Cool. So now, this, spoiler alert, is also true. It's going to be very useful later, but that isn't going to be a problem for your homework. So, have fun with it.